Okay.
And we are live. Hi.
Hi, everybody. I'm Annette Kempf, and I'm an electronical engineer from Germany, working in the field of embedded software. I started early working on embedded software development, still with 8051, for software on blow molding and injection machines. And then I switched to automotive, which by the time end of the 90s, beginning of the 20s was really, really interesting because in the beginning there was not so many parts which were having embedded systems, and then step by step we we did a lot more in terms of embedded development. And I started in the combustion engine domain, where in the beginning you almost had no components, and then the regulations on air pollution got tougher and tougher and tougher, and this resulted in adding a lot of components like nav sensor and so on. So the software has been growing from like 100,000 lines to 2 million lines of software code, and was the time I was growing in this domain. And later on, I step by step switched to electrification of a powertrain, which now is getting more and more important.
So,
And yeah.
so you talk about 1997, right? 1998. Is this what's happening in the embedded world in that time in the automotive? Did the cars have some electronics that were using what kind of software? What is going on back then?
We had, like, for example, we used from Infineon the C176 microcontroller, no, 67, I switched around. So it was still a small microcontroller. We didn't have the architecture concepts we have right now. So we, even from a high level software, we directly accessed some of the peripherals. So we had to learn architecture, better concepts. And what's also was coming there is the first steps of functional safety, which are standards right now. By this time, the standard was called EGAS and was from Bosch. And it was the first step, which is now implemented in the so-called ISO 26262. You had, step by step, you had to think about transferring functionality, which was from before in mechanics, now into like electronic and software, and the whole community was learning a lot. So it was a lot of young people. It was really, really fun. And we had the chance to take decisions which many people are not allowed to take today anymore. So we had teams, we had really technical team meetings and discussed, and then said, yeah, we'll do like this. And we went to our boss and said, we thought this would be a good solution. And he said, yeah, okay, try it out. So I really enjoyed this time.
So, were you? Does it have to do with stuff like ABS? Like right now, with if you turn too much, then the car automatically just like doesn't overcompensate before. I guess I don't know if that's got anything to do with that, or was it going over the CAN bus? And what was it actually doing?
It's more or less, you have in automotive, you have the division powertrain, which is transmission, combustion engine, and now electrified powertrain. And then you have, for example, chassis and body, where you have airbag and so on. And then you have navigation systems, and it's another like big column, and it's almost no exchange. So people are sometimes changing companies, but once you were in powertrain, you will always stay in powertrain. So I never had anything to do with ABS, to be honest. So I worked really in transmission and combustion engine. And for combustion engine, maybe you know Euro 2, Euro 3, Euro 4. This is the European standards. And also for the US, you have legislation where it's connected to the air pollution. For example, you have to, if you want to sell a car to the US, you have to comply to requirements defined by the CAB, California Air Resource Board, where you have to do all different sort of diagnoses for the combustion engine. And these diagnoses, for example, were also growing. In the beginning, we had some diagnoses. Now it's around 1,500 diagnoses for each and every input pin, for each component which is connected, and so on. So it was really growing the software, and by growing step by step this software, you had to learn a lot how to structure it, and of course you have to understand the growing functionality, because in the beginning the dependencies were not so important. By a combination between air, mass flow, different temperatures, exhaust gas regulation valve, where you put the exhaust back again as input air, and then the control algorithms got more and more sophisticated. And of course, with the teams growing a lot, the communication structure in the company also had to change.
So what goes into when a car is emitting CO2 pollution? What goes into the whole embedded system that takes care of that, or that measures that, or all these diagnostics? Where is that located physically? That an engine, the stuff that you're doing there, can you explain a little bit? And this is something that started happening 20 years ago?
More than 20 years ago, yeah. But in the beginning, it was like very, very basic, and then it got more and more sophisticated. So, for example, I started in gasoline, and then I changed to diesel. For the diesel system, you have a high pressure pump. You have we had piezo injectors, which can open and close even when you're injecting for one cylinder. It's not just one injection. You have pre-injection, you have main, and you have post-injection. So you open this piezo injector a very short time and close it again, open again and close again. And this makes a very smooth combustion process. And this is enabling you to have less emissions. So in the beginning, of course, it was just very basic valves and just opening once. And then you had this exact opening and closing and ensuring a perfect burning mechanism. And of course, you have the air flow from the outside. You have to know all the temperatures. You have the exhaust gas valve regulation, recirculation, where on the output you take it back to the input, a part of the exhaust. So you're not only taking fresh air, but also exhaust. You have, of course, the pedal value sensor, which is for taking the speed. You have a brake. You have which is challenging is the air conditioning. Most people don't think, but it's generating abrupt torque losses. And then safety functions might find something which is not intended. So you might think you have an error which is not an error because you just started the air conditioning, or you're stopping the air conditioning again. You have a filters, you have, I don't know, you have around 50 components, different sensors in all the burning path. Yeah, you have, when you start the car, the starter, you have mild hybrid, where you have towards electrification and so on.
Maybe I'm playing one of the videos that you have. is that like a big jump in the present compared to what you were talking about from 20 years ago? But what does the video talk about here?
The video is talking about the CentBus protocol, and it really didn't exist like 20 years ago because Cent is a protocol which was introduced to replace analog sensors. So if you have an analog sensor, you can have like offset errors, which are not exact. And this protocol, many people have a problem to understand it in the first place because it's based on time. So what we see now is the scale. So the first part is really giving the timing, and then afterwards you really get the data information. And as it's very basic and not communicating a lot of information, it was designed to communicate two analog values. Instead of analog sensor, it's like a digital sensor which is giving the information by the time without having a clock. So it's very special, and it was, I think, introduced in 2003, but I'm not sure about the date. It's not very old.
And so is this a bunch of Infineon stuff what would be the chipset? What's the architecture of those, and how do you program for them?
What's used is in this field, it's either Infineon or Renesas or NXP. So I saw these three, which have solutions for these demanding automotive implementations in terms of timing. So I worked most of the time with Infineon. So we started with Infineon, but in between where I worked, we had also all the OAKs, they were called, from Freescale microcontrollers, which are now NXP. And then we switched to Infineon back again. But it's not so easy because it's the complex microcontrollers. The last time I worked was with Infineon, and the handbook of this so-called Aurix microcontroller has around 5,000 pages. So it's not that you can switch like every day, and they are very sophisticated peripherals, internal buses, and so on. For Aurix, it's the GTM module, which was specified by Bosch, which is designed especially for these timing topics. So once you chose one microcontroller, to switch is not so easy. It's not as difficult as it was in the past. This is something which really also changed. In the past, the chip producers did not deliver something like an MCAL layer. And now you get the basic software, which is controlling these peripherals. You can buy, and it's standardized. And then you have a clear interface, which is the same between like Renesas, NXP, or Infineon microcontroller. Sounds easy, but for electrified powertrain and also for combustion engine, the MCAL are not sufficient, and then you need so-called complex device drivers, and then you're back again really close to the microcontroller, and you have to read the manual, and you have to understand, and you even have to understand the MCAL you get delivered, because you are sharing resources with this, and then it could generate problems if you're not looking into all the details you need to know.
So I guess these chips have a very high reliability, very long life, and I guess maybe over the last 10, 20 years, would you say there's been a lot of performance improvements, or is it just pretty much the same, just trying to make it simpler, kind of? Or how would you define it? Is it are they ARM processors? Are they using the ARM architecture or something different?
NXP is now changing to ARM, as I understood, but before it was the Motorola architecture. So it was Motorola, then Freescale, and then NXP bought it. So it was the Motorola architecture, which also generated some problems because for Motorola and for the other architectures, you have a different endianness. So you have big endian and little endian, which is then generating problems if you are communicating via bus and so on. So you have to take care if you're switching in between. My understanding is that the next generation NXP will be based on ARM. For Renesas, I don't know, to be honest. And for Infineon, they are staying with their architecture. So it's the Aurix, and they are the next generation is still based on this. So you have the core is a tri-core microcontroller. It was called tri-core, and then they added several cores. So this is the point you ask about complexity. The complexity has been growing a lot. So the functionalities in the car have been growing. There are a lot more features inside. You changed from single core to multi-core, which caused many problems. And of course, the chips are a lot more powerful than they used to be.
What's the advantage of having a more powerful chip? You call it the transmission, right? What does it change? Does it optimize range like crazy? I guess maybe the new electric cars have also a bunch of stuff happening, but are completely different compared to the combustion engine kind of calculations, or is maybe similar?
There are some differences. Like for the combustion engine, you have many sensors and actuators. You have many parts connected. So you need lots of pins. This is one thing. But you're slower in the calculation. I would say for the electrified powertrain, for the electric motor control, it's less complex. The software, it's not that big, but the timing is a lot more interesting. So you have to the so-called field-oriented control. And here we see the clock transformation, which is the basis for field-oriented control. Anyway, for each electrical engineer who is female, this is interesting anyway, because she's the one electronical engineer, which for us means a lot. And the first one who really gained popularity and was admitted to this US circle of engineers. And looking at this, you have the transformation, the clock transformation, which is the basis to have, before you have 3 axes, which is resulting in differential equations you cannot solve. And by doing this transformation, you have 2 differential equations which you can solve. And this is the basis for the so-called field-oriented control to control the electric motor. And what you see here is one of the things my company Eclipseina is doing, because we are doing trainings, especially in this field. So what we are seeing here now is some short trailer video, which is giving an insight in how the trainings are built up.
So there's a lot of mathematics going on in there, or do engineers that work in this field need to know all their maths, the mathematics, to get all the calculations right? Or
if you do work in the field-oriented control and the control algorithms, you should have your mathematics and control algorithm know-how, including Laplace transformation and set transformation. You should know. but in these kind of projects, you have different roles. So some people really need to know these things. And of course, you for each control unit you also have all the communication via LIN, CAN, FlexRay, Ethernet, all the different bus system. You have your input and output components. You have your diagnostic event manager for all the diagnosis you're doing. So you have, depending on your architecture of such an electronic control unit, you have different roles in the team. So even if you're using the same tools, and even if you are like all programming in either in C or in MATLAB Simulink, some people really need deep knowledge in the microcontroller which is used. Other people need a really deep knowledge in the control algorithms. And it's not only the control algorithms and the math you have to know, you also have to be interested in the system, because it's not like that you're just software based. You are controlling an electrical machine, and this electrical machine is moving. Should in some cases move, in others no, and it can be like in motor mode, in generator mode. You have a connection to the battery. You have also, when you charge the car, you have a charging. So you have all the different states you can have. So you have a car parked, you have it charging, you have you start driving, you're driving fast, you're braking, you have a connection to the brake because you have recuperative braking, so in the generative mode, and also you have the braking which is done by the brake system, and of course then we really have a connection to the ABS. So and this makes automotive complex, because you cannot say, aha, this is my software architecture and I have some asynchronous communication, I'm done this. It's control algorithms, and this is all happening at the same time, and you have to make sure that the reaction is correct and that you're not causing any accidents or acceleration or deceleration, which is not supposed to happen. And of course, you also have an energy flow. So if you're braking hard, maybe the battery cannot take in all the energy because the current is too big. So you have to make sure that the amount of energy you're sending to the battery is correct. So you have to control all this all the time, and you have to connect the different microcontrollers or the different control units. And the challenge is in the timing.
So is there like a automotive OS that kind of links everything somehow, because all these different microcontrollers run different things at the same time somehow, and it has to be synchronized? Or
it's called E/E architecture, but right now there is not an automotive OS. I know that Tesla started to have it more centralized, and now step by step other OEMs also are taking this step. For some of the ECUs this will work, but for others this will be difficult. So on the one hand, of course, you have the logic, which should be close together, but on the other hand, you also have your system, which is for example, for the electrical machine control, you have power electronics, and you have switches which are switching quite a lot of energy there, and you have to be close by, and you have to make sure that this timing is considered. The same is maybe for brake and ABS, which are often also done by other suppliers. The idea, of course, is to step by step to have reusable software. To a certain extent, this is possible. And then we also have one training, and we're starting to do more. There is a standard called Autosar, which was defined for the automotive industry, and it's defining the basic software in detail, all the drivers which are connecting to the hardware, and also this so-called diagnostic event manager for the diagnosis. And then you have an interface layer. This is the real-time environment, which is connecting then to the application software. And this standard has been defined by the Autosar organization, where the big OEMs were the founders, and then the big OEMs and also tier ones, and they defined this standard. In the beginning, it was just called Autosar, which was only the classic platform, and now with this going more to an automotive OS, like you said, there's also adaptive Autosar, where they are still in the process of defining. So there was something released, but the changes are quite big. So we started our training, to be honest, with the Autosar Classic, which is more stable. Yeah.
So I guess it's a big challenge to make everything work in a car, and I guess it's getting more and more complicated right now. And like the new trend is a little bit to do the electric cars, right? And what do you do with the electric cars?
One of the trends is electric cars. Also, another trends are like autonomous driving, where I'm not so involved. And for electric cars, you need know-how again, which many people forgot in the past. So when I studied, we had for the electrical machines, there was almost no interest. So this was old stuff, didn't change, not interested, was in only used in industry projects, and there were not so many jobs. And what we see here now in the video, this is like the communication between the charging station and the vehicle. So people have to now work with more electricity again, which they did not do in the past. And this means there is a high need of learning all these things. And the need for understanding more electronical engineering is coming due to the fact that the people worked more with understanding mechanical parts in the past. And now you have an electrical machine and you have a high currents, not very high currents, but it's enough to kill someone. Yeah. So you have to make sure that you have, it's called high voltage safety. Just for an understanding, in automotive, high voltage is not the same as in power distribution. So if you have like a power plant and power distribution, then this would be low voltage, which is called high voltage in automotive. And then people working in a car repair shop have to learn this, and also all the engineers. So what's happening right now is that the people who used to work for combustion engine projects are switching step by step to electrified powertrain. And of course, they need to understand all the changes. The interesting thing is, like you said, with the car architecture from the vehicle, these people who worked in combustion engine, they still know their interfaces. So they know the interface to the rest of the car, to for example, brake, ABS, and how the communication is usually working. Then you have a lot of know-how also on the microcontrollers, on the drivers, and so on. So this know-how is there. Also, the interfaces are there. Not only the interfaces of the software, but also working with the customers and so on. So because the same people who work for combustion engine on the OEMs are switching to electrified powertrain, and also at the tier ones, but to understand how an electrical machine is working, how a power electronics is working. Power electronics is the electronics is also a big difference, because before you had just small currents, and now you have higher currents. So before it was more digital design. Now you need analog hardware design. So these are changes too. And of course, what we saw now in the video before, they are also for the charging mechanism, the interface between the charging station and the vehicle. There are some standards, and there was quite a lot of chaos with new standards like it is. So you have, like, the Chinese have a standard, the Japanese have a CHAdeMO, this we see here is the European standard. The US will do a different one, which is similar but not the same. And this is also generating problems. It's called interoperability. And you would expect that by now each charging station can talk to the vehicle and that the charging is working fine. Not the case. So some charging stations are talking to some cars, and so not the whole community of charging stations can talk to the whole community of electric vehicles. So you have some good and some bad combinations. There's also a big challenge in this direction. And there we are not only doing e-learnings, we are really working on the electronics too. So we defined an electronics for the charging station, which is doing the communication, because then the standard, the European standard, has gaps where the timing is not defined very well, and some other things were not done in the smartest way from a standard point of view, and this is generating many, many problems. So we are working on this too, to have electronics for the charging station, and also a test system which is doing these interoperability tests to a certain extent, because the different standards there also have some test cases. And Germany has started with a DIN norm standard and then switched to the ISO standard. So you have some charging stations which are still according to DIN, and then the ISO is different. And there's one thing they changed in the standard. It's you had 1 byte for the DIN, which was don't care, and they used it for the ISO to define whether the signal is encrypted or not. And they chose 0 for encrypted, which would have been the normal default before. So you have a problem that all the DIN relevant usually put 0 for don't care, and then it's expected to get an encrypted information. This is like one of the examples why it's not working, and there are quite a lot more.
Has it been interesting? I guess you worked over the last since '98 with the German car makers or the French, or and has it been an interesting, like, do you think that there's a lot of talk of trying to make things better in the future, especially now that everybody's talking about EV?
Yeah, I worked for different car makers. So I worked for BMW and Volkswagen, but also for Ford, Land Rover, Jaguar, so Renault. I now also did some Opel, which is now Stellantis. I worked with Fiat Project, which is also now Stellantis. So I worked for quite a different car makers, because I was at a tier 1 and we provided solutions for different car makers. And I also had a team. So I was not only working as a developer, but also as group and department leader. And I had some transfer case and transmission projects, also for Borg-Warner, for example, and ZF. So I saw quite a lot of different tier ones, which were delivering components and electronic and software, and the OEM side. My feeling is that currently things are rather moving backward, and then there are lots of problems. I don't know where it all comes from, but this was kind of a motivation I had to start the Embedded Academy, because I had the feeling that there is a lack of know-how and a lack of discussion how to do the things real good. So there is a pressure in terms of timing, but I had the feeling that in many places they just stuff in software, and sometimes we even called it shit in, shit out programming. So you get some requirements, you just do it exactly like it's requested and not think about the consequences. And I think this is the reason why there are more and more problems in the automotive industry. And we have to get back to the know-how base and really think of what it means. And it's not just that you look at the software function. For example, for the electrical machine, you have your control mechanism, but then you have you're switching some IGBTs or MOSFETs, and then you have a inertia of a machine. So it takes time until it's accelerating or decelerating. Then you have a sensor, which is measuring this rotation. Then you have some entrance filters, because if you have like a high voltage or some noise on this, then you could break the microcontroller. So you have some filters there. Then you have your basic software, and then you have a signal. So your signal which you're receiving on, which is giving you the position information, is old. So you have to do an estimation where you are. And this means the control mechanism, control algorithm, or you have to know, is not just like the controller you're designing in the software. You have to have have to know the whole path, and to understand the full behavior. And for this, you have to be interested in the overall system to understand what's happening there, which timings you have, how the different parts are interacting. And I see that there is a lack of knowledge. So I don't know for other countries. In Germany, they reduced from 13 years to 12 years for getting the high school diploma. They switched from the so-called diplom engineer to bachelor and master. And some of the students just study 2 or 3 years in theory less than they used in the past. And then, of course, you cannot expect them to have the same know-how like in the past. If you have 2 or 3 years less of studying, then you need to learn the things. And companies need to train their people on exactly on the job they are supposed to do. And this was my motivation, because I saw, first of all, you have to switch from combustion engine to the electrified powertrain. And in general, you need to learn the things. So we started with some standard embedded things, also in German. Right now, we are switching more and more to English, because the international interest is higher than the German interest. And then we step by step were going into the electrified powertrain, but we will not stop there. So we have some general automotive know-how, like what we saw for the basic software and the rest of the architecture standard Autosar. We are also doing the process framework on Automotive Spice. and we have this electrified powertrain. But many things we're doing in the electrified powertrain, of course, you can use also outside in the normal world. So we have some electricity, magnetism basics, we have information on the electrical machines, we have a training on the Park-Clark transformation as one part, and we have what we also started early with, a training on encryption. So there you have historical ones and all the typical encryption mechanisms which are currently used. So we'll continue.
There's one comment right here from D. Fragler. Time constraints are annoying. They exist in the software industry a lot. One thing that I'm wondering is, with all the chipsets getting better and better and more crazy powerful and everything, and everybody wants to add more functions, and the electric cars are doing, is that like, even though 20 years have gone by, but every time they launch a new car, they're like in a rush to get things out, and it's just copy and pasting and not making things like perfectly smooth? Is that a little bit, does it make sense when I'm asking?
Yeah, usually, or what I know is that you usually set up a product line. So you really have a software product line. The tier ones are providing the similar software to different OEMs. So it's not that you start from scratch. Usually you never start from scratch. You have something which you are reusing, which sometimes is going beyond useful. So for the combustion engine, we had so-called variables which you could calibrate later on. And there you have up to 100,000 values, which after the software is delivered, you're configuring and optimizing the motor. And for the electromotor, it's not that much in this direction, but as you are working with the same people than before, on the OEM side who worked with combustion engine, they ask for these parameters again, although you don't want to do it, but they are asking to do their parameterization themselves and to have some freedom. And of course, with freedom, you have to test it and to make sure. This is one aspect. And with the timing constraints, this is getting more and more difficult also with the multi-core systems. So your software is not running on one core. You have maybe 3 cores is often used right now, and then you have to make sure that you distribute the software in a good way, and that you don't have happening that you lock each other or that you have race conditions. So you have to make sure that these timing issues are taken care of. And with these like more software and multi-core systems, this is getting more difficult, of course.
So here we have another comment. Thread safe and locking is important. Software has got a lot of reusable library. It should do the job they need to do. Does it make sense what he's commenting right here?
Yeah, software has a lot of reusable libraries. This is true. And this is what each tier one is building up. So they are trying to have a product line, to say they have one reference architecture, which they are using for each similar project. So if you have an electric motor, then if you have like an induction machine or a permanent magnet synchronous machine, or which machine type you have, how many pole pairs you can have, and so on. And of course, you know your hardware design, which is also reused. So then if you have like a 2-level, 3-level inverter architecture, what parts you're using, which chips you're using. So it's not only the main microcontroller, there are some also other intelligent chips you've been choosing for your hardware. You have your hardware software interface. And of course, in the whole context of the product line, you try to do as much reuse as possible for the next customer.
There's one more question right here. If I understand it correctly, they create a generic interface on which they build up modules. Is that relevant?
Yeah. If you have a reference architecture, then this means you try to have as much as possible generic interface. And in addition to this, like I said before, with this Autosar standard, some of the interfaces are really defined in this standard. This is more the basic software, which is close to the hardware. And there really the interfaces are clearly defined. And this is something where the automotive industry said, okay, this is not distinguishing and this is not really a product relevant, so we can share this know-how and make sure that this reuse can be established. And for example, there you can buy the stack from Vector or Electrobit, or I think KPIT also has one. So then you have the basic software stack, you have interface mechanisms. The problem there in this standardization was there were too many people there, and there are too many mechanisms allowed. So you have redundant solutions. You don't have like one not only one solution for one problem, but maybe multiple solutions, and this is not optimal. So it's a bit too much in the definitions. And coming back to then the upper part, where your own product line is, and you have your so-called application software, of course you try to do a reference architecture, and this reference architecture means that you're trying to have at least the component architecture the same. And then, of course, you're defining standard interfaces with the same resolution, if possible, or you can also calculate at the interface, but it makes sense to have the same resolution and the same kind of interfaces.
So working in the industry over the past years and recently, and in the future, are there some kind of conferences where you meet with the different car makers and kind of like try to suggest or talk in a discussion what should be the standards and what they should to make things better? Because can you define a bit more why you think things are getting worse and which aspects? Or is it just getting more complicated?
Yeah, but I think, it's getting more complex, and sometimes we make it more complicated than it should be. So this is one thing. And of course, automotive has lots of standards, but I sometimes it's had the feeling that they define standards 10 years after the industry, the rest of the industry defined other kind of standards, because automotive only looked at automotive. So it's like reinventing the wheel sometimes. There are standardization meetings, but with this Volkswagen scandal for the diesel, the activities almost stopped, because before there were quite a lot of meetings so-called in German Arbeitskreises, like work groups, and where you exchange the things which are not necessarily important for one car maker to say, okay, we can standardize this. For example, for ODX standard, there's a standard called fault symptom exchange description, which is an add-on to the ODX standard. And there I worked in a work group for all these diagnosis information. and to say, okay, if the OEMs are receiving this information from the tier ones, it has to be clearly described. So all the diagnoses are kind of in kind of a domain-specific language. It's a clear description, and then they only need to review and take some things out or modify a little bit, and then they can send it to the US CARB, California Air Resource Board, to have this in the so-called summary table that they can, I don't know, have a type approval for the US. So this is one of the standards. And of course, Autosar is one of the standards, but I think main thing is really that the complexity has been growing a lot. So there is, if you look at older cars, and if you're also driving an older car, if you go like 150 kilometers per hour with a very old car, you have a lot of noise, you're by far not that safe, and so on. And with the modern cars, you go 180, and it feels like in the past going 80 kilometers per hour. So you have a lot of changes. You have airbags everywhere. You have, I don't know, the multimedia, you have a head-up display, you have the new emission standards, we are going towards autonomous driving, you have automotive, automatic parking functions, you have automatic distance control. There's so many new functionalities which came in recent years, and this is how the amount of software code has been increasing a lot.
Does this mean that the teams grow to get a car out on the market? Would you say Tesla came and kind of gave a punch, or would you say a wake up slap or something to the industry? Like what do you think is the influence from Tesla?
It's interesting, the influence. In the past, we in the industry we said if a time schedule is completely crazy, we said it's harakiri, yeah. And now it's called Tesla Tesla timing. So we have to finish in Tesla timing. This means for the tier ones, it's completely unrealistic and crazy, but we try to make it. And I think this is really explaining Tesla. The thing is, for Tesla, I think they have lots of problems still. And imagine a BMW would have done it the same way as Tesla. This would not have been possible. It would not have been accepted by the customers. So as a newbie, it's okay, and the buyers have been accepting also a lot of deficiencies, but Tesla still has a lot of bugs and deficiencies inside, and has been growing fast. And it gave a push to the rest of the industry. And they are slower, but I think they are trying to do it in the way they used to do, like with setting up a product line, with setting up reuse, with doing lots of testing to be really sure that it's working. And for example, I had some A samples where we were 2 years before series production and the car was driving fine already. But then you need all the diagnosis, all the things, and especially with the Dieselgate with Volkswagen, the authorities have a very close look on the German car makers, where they cannot work in the same way as Tesla. It's impossible. They really cannot do this. It would not be accepted, right? Neither political nor from the buyer of a car.
But now the political guys and girls in the EU are saying it needs, like they're pushing even further and saying we really have to get all cars electric in like 5-10 years, right? And like more and more car makers are saying that they're switching away and just doing only electric. Are they all going on Tesla time now?
No. I would say the first electrified car I worked for the project was it was then stopped by the OEM themselves. We didn't understand, and we had the electrical machine and the power electronics and everything working, and this was in I think in 2001, so it was quite a while ago, and the suppliers have stable solutions, and the cars will now come step by step. So Volkswagen has quite a lot of cars on the market yet already. Also, Opel started, BMW. You will get a lot of Mercedes cars. For others, I don't know, but I also saw that Hyundai gave a big project. I saw in the press that Vitesco will develop this. So there are a lot of electrified cars on the market. But maybe we can look at this charging topic again, because there is the issue. So there are not so many charging stations. There are not so many possibilities to charge your car. If you have a private home where you have like a private plug, it's okay. But if you are living in a city, in a where a bigger block is, in the garage, you don't have possibilities. And also while driving somewhere, there are not so many charging stations which are available. So on this market, a lot has to happen, because you cannot sell the car without providing the means to charge it.
Maybe I can switch over to your slides right here. What I'm wondering, maybe you can talk a little bit about, you just mentioned a car from 2001. Can you mention a little bit? Is that a secret who it was and what it was? What is, because sometimes I wonder if it's some kind of weird politics, or not really politics, but like, you know, I guess the word is oligarch. The oil industry wanted to survive or something like that and stay relevant. And then now there's some forces in play that's trying to move everything to electric.
I'm not sure where the problem was, because we thought that it might have been the battery. So we only did the part with the electrical machine and with the power electronics and the software for the electrical machine. But you also have a battery part. And I don't know if there's so many things behind which you don't know. If you're working for a tier one, you only have a part of the overall vehicle which you're supplying a small subsystem, and you don't know about the rest. So it could have been that they had problems with the battery package, or even with like production of a battery. So this I cannot tell.
Yeah, the batteries weren't as good 20 years ago, for sure. Mm-hmm. But I always thought that it was just somebody needs to do a standard for battery swapping. Even though there's batteries are heavy and there's a lot of power going on, the connectors need to work and everything. There's always been some talk. Some people might, like a Better Place had a thing, and now they're talking about battery swapping a little bit in the US, and China's doing battery swapping. I wish the industry had a standard for that and just made it more easy. But that's a different question, I guess. It's
I was in contact with Better Place in the past. I think they were just too early.
Yeah, they were. Yeah, it was an awesome idea, but too early, right?
Yeah, too early. So the timing was not the best. Yeah, because the idea, of course, it's not so easy, because it depends which kind of vehicles you have. Maybe for light trucks it would have made sense, and for the normal passenger cars, the problem is that you try to optimize and fit the battery perfectly in, and you have to make it crash safe and so on, and you don't have so much space. And then it's difficult to say, okay, you have enough safety space in case of a crash. And you could swap it. But for the light trucks, I guess this would be possible. So maybe Better Place can start again.
I have this theory. Sorry, my camera is a little bit gone, but I have this theory that I'll replace the battery. That maybe the chance for the European car makers against Tesla is to just embrace some kind of standardization around the battery swapping, and then I think that would give them a chance. But I guess it's complicated for all these competitors to agree on size and weight and everything.
Yeah, and I don't know in English now the term. It's Bauraum. It's the space where you put the things in. This is always a big discussion, and this is even a discussion if you only have like such small control module. So I guess for the battery it will be really, really difficult, because then you would have to have the same size of car below. That also the wheel distance and so on, I think it would need to be exactly the same. So you can only define like a common platform and say, okay, for this common platform, this is possible. And I think this would be only possible for the big ones, like Volkswagen, they could do, yeah.
Because I see so many cool cars, an amazing car, very affordable, hatchback SUV, and it's so trendy, and some are like less than 10,000 euro now. But I wish they would just like embrace something. Okay, that's just a different political question. But maybe how about we get to your slides where you're talking about your product, like your company. Maybe I can go back in the slides right here. Maybe you can talk a little bit about. So what do we see in your slides from here?
Okay, this is the company Eclipseina. And what we saw before is, Eclipseina is my company, and we're doing several products. And
10 employees you have?
Yeah, maybe you because we've been looking more on the e-learning topic now, and there the interesting thing is that we are really combining different things. We have the technical knowledge, and maybe this is also interesting to see if you're working as an electronical engineer in such an environment where everybody else is doing the same job, then after a time you're happy to work with some people who have a different background also. And by introducing this e-learning with the Embedded Academy, I have a chance to work on the technical level, but also on didactics and design and animation and knowledge management. So we are combining everything. And this means also that the team is a mixed team of different disciplines where you can only achieve as a team a lot together. So you have really these different views and discussions, and then you create something which nobody else has. So we're not just doing e-learnings like this conversation here, where you see like a face and in between maybe a little bit of information, but we have the technical animations, and you have interaction, you can choose your buttons and so on. So we're really taking you on the journey of learning and give you the chance to interact and learn. And there in this slide, we see the different columns. So we have the dark blue one it's the background technical know-how you need to have. And then we take it, for example, to one application. So we have electric charging. I see that I forgot the check mark on electrified powertrain.
I think it's my thing is reformatting your slides. Sorry, I did an import of PDF to PowerPoint to do this. Yeah, sorry.
And then the electrified electrified powertrain needs information like electronics basics or magnetism and so on. So we take you on the technical things you need to know for the electrified powertrain, but of course we ask you to learn also the background information, that you understand everything which is connected to this. And this is one of the concepts that we have different units in the background, because some people need this information and others say, okay, I studied this, I know. Yeah. And maybe we can look at the like the first step we went in was the motivation. This is the roadmap. Which I can also explain. Like the roadmap is many things which we are doing is connected to automotive. This is why my background. So we have Automotive Spice, which is a process model on how to do step-by-step development. And then we did the focus on the engineering. So the first things we implemented was like an overview training, and then all the system and software engineering processes, and we'll continue. So we try to cover everything, but it's step by step. For Autosar also, we started with an introduction and with an overview training on the Automotive Autosar Classic. Virtual function bus is the bus interfaces with a standard for communication. This will be finished maybe April or May, and then we'll go into the ATOS. We have some embedded basics, floating point and fixed point. This is the only one which we did not yet translate from German into English, will come soon. And we have Park-Clark transformation, which is one important thing which you need for the electrified powertrain. For IT security, we have the historic cryptography and the modern one. And for electric charging, we did the electric charging communication, and for the electric powertrain, we did more or less the basics, the power electronics, the electrical machine, the control of the electrical machine, and battery systems is in work and will come soon too.
So who can join your embedded academy? And can people sign up on the internet and do it remotely? And
yeah, it's a web shop, so you can buy a subscription, and the subscription is for 1 year, and you have access to everything for 1 year, meaning from what's available right now and what we will generate step by step in the future. And recently, in January, we signed a contract with Vitesco, which is a tier 1 for exactly this field. And some of the e-learnings we'll do now with Vitesco together, which of course enables us to speed up the process of generating new content.
So are they, for example, looking for many new engineers, and are there many people looking for this kind of job?
I would say, yeah, you have people who are looking for the job, and even more you have at the OEM and tier 1 side, all the people who are now switching from combustion engine projects to electrified powertrain. So they have a certain know-how, and they have to switch the position within the company. So they are usually not looking for a new job, but they are staying in the same company, but they need to acquire new know-how in order to be able to work efficiently for these other kind of projects.
And where are they based? Which country do they live? Maybe the people working in this space.
You have where the OEMs are. It's like in the Asian market. China started with electrified, so they don't have so much combustion engine, but you have Korea, you have Japan, you have the US, you have a lot in France, Spain a little bit, Italy, UK, and of course Germany. And this is for OEMs. Then you have a tier ones, which are in similar countries. And then you also have the service companies, or I don't know, the development services, which where you have offshore development. And there's quite a lot in Northern Africa. So you have, for example, Valeo has a big location in Egypt, you have in Tunisia, you have in Morocco, and of course a lot in India. And in Europe, it's also quite a lot of development in Romania, also in the Ukraine, so Hungary. So you have quite a lot of countries where the people are located who need this kind of know-how.
Do they all connect with you from all these countries and sign up?
To be honest, we just launched many of the trainings, so we're just in the process of getting these customers, but they have contacts to quite a lot of different countries within Europe and also outside of Europe.
All right. Yeah. So maybe thanks a lot for doing this presentation. Maybe are there some things we didn't cover that you think I should have asked you?
Maybe we can have this one slide with.
Do you want to screen share it from yours, or should I try to find it on next?
Maybe I can screen share it on mine.
Is it this one? No.
No, it's the one where you see the timeline.
Yeah, please, if you can add the screen share in your timeline. Okay, should I go back then maybe?
Yeah, it's the motivation and the timeline. Oops.
Okay. This motivation. No. Yeah, I'm not sure if I have the same. Yeah, are you screen sharing your? Can you try to click?
I will. Maybe? I need to open it first.
Yeah.
No, this is not the right one. Introduction and roadmap.
So like there. Yeah, I see your screen. You can maybe do it full screen if you want. Yeah.
How is it working with?
Maybe are you gonna link to the slide? Somebody's asking where can download the slide. Open the door to Algerian startup.
I have to check if we can communicate all the slides if I want to provide them, but I will do a subset of this.
Maybe you can answer the comment on the video under if somebody asks, then you can answer over there. So now you can comment. I'm sharing your screen.
Okay, so more or less like our motivation coming back to this was really the future needs. So we have technology change in many areas. So we have autonomous driving. We will do something there too. We have interconnected production. We have, in general, digitalization. We have electromobility, and we also have decentralized energy supply. So there will be a lot more topics we are going to cover. And this means we will have more and more people working in the embedded domain. It has been a growing business with like 12% growth in the last years. And this means you need, of course, the solid fundamentals where people coming from the studies, they have gaps. You need the contemporary know-how, what's up to date now, and you also need some knowledge about the newest technologies. And what we see here was like kind of a motivation, because some people, they are even, I would say, from the people I know, they are sometimes afraid to ask for trainings or to admit that they don't know things. And from my point of view, it doesn't make sense. If you say, okay, in Germany, you have to work until you're 67, in other countries will be a different age. But this means like the average engineer of 2021 is 45 years old and has done a university degree in 99. And of course, if you're working in the embedded domain, it's not necessary that you studied the same subject. So some are mechanical engineers, electronical engineers, others studied physics or maths or computer science. Yeah? And of course, there are gaps. So if you ask someone from mathematics, they might not even know what a PWM signal is. And if you ask some mechanical engineer, they might not even know what a software class is, where the computer science people say, yeah, but this is like in the first lessons you learn this. So the gaps are from the curricula of a university, and you have to fill the gaps. And during your work life, you will not do the same job all the time. So you have job rotation, you have new projects, and of course you have new technology. And so the needed know-how, it's changing, it's constantly changing. And also you need to update know-how. So if you studied, for example, electronical engineering 20 years ago, and now someone asks you for your electrical machine know-how, you might not know like the some of these Bode Nyquist and other diagrams anymore, or you're not able to calculate. And sometimes people also don't want to admit that they don't know, and this is giving them a good chance to update the know-how, maybe even without asking the boss. This is one solution. And of course, for companies, they can give the people the access, and then they might do an extra lesson, which was not necessarily planned, to get the know-how back again and to be able to show in the job that they really know what they are doing. And below you see like the timeline, the same timeline we put like as an average above, looking back. Yeah. And I'm not that old, but I can still remember the discussions on cruise control. If it's really okay, if a vehicle will keep the speed without the driver touching the gas pedal. Nobody would discuss this today anymore. But these were really safety discussions which took place in the past, where you didn't know how the legislation, how the drivers would react, and so on. And we have a lot of technology change, and people get used to all these things fast. But if you look at this, like the basics in the past and what's coming to have fully autonomous driving, this is a lot of software, a lot of input-output bins, radar, LiDAR, camera systems. And of course, you need to increase the staff and you need to increase the know-how there.
All right. So you said 10 employees, and you will be able to cover all the different topics and everything, and somehow and organize the knowledge in a way that makes sense, not only as an education platform, but also, I guess, in a work ethic, or what do you call it, like getting more efficient and getting all the stuff done for all these companies that need to switch to Tesla time a little bit, if I'm a little bit joking, but to...
Yeah. So of course we'll increase personnel. So we started increasing. It has been like my personal, I don't know, my personal motivation. So it's all my personal money which went into this. Quite a lot of my hard worked money within the automotive industry I put into this project. Now with having the collaboration with Vitesco, we are speeding up quite a lot, and we will increase the team. So within the last 4 months, we produced half of what we have now. So we really are picking up speed.
All right. Thanks a lot for talking about your company and what you're doing and the industry to try to understand what goes into every car. There's like so many millions of cars. I don't remember how many. Is it billion cars or I don't know how many million. There's so many cars and they all have embedded systems and they all need to just work and not like crash into walls and everything.
They have 100 million lines of software code inside.
Each of them.
Yes, each of them.
Nice, and hopefully there's not too many bugs, and it just works. And it sounds amazing that the industry and the experts that go into making this real, making this work, and I hope it's like a fascinating kind of job to have to work in this field.
I always enjoy it. So and you look at the cars. I also remember I was in Romania for 2 years, and I told to my team, if you come to work the day during in the morning, look at the cars, and in the future they will all drive around with your software. And then my software team said, yeah, and I looked at the cars, and it really makes a difference. I'm working for this. So then you see the product, and you see the product every day, and you think, I worked for this and this car and this car. So it's something special.
I'm renting right now a Dacia Sandero, and it's just completely amazing. And I checked on the internet; it's a car that's only 7,000 euro, kind of a little bit more, maybe 10,000 or something. And it's just amazing what the car companies are doing. Like the modern cars are so smooth and amazing and affordable. And I guess it just needs to get better and better. When the economy, it seems that the cars, the demand is not slowing down, and there's not enough chips for all these. So I don't know if those chips that you're programming on are part of the problem also, if it's more like different kind of chips that are in short supply. But okay, that's another hour we could do, right, about all this stuff.
Yeah, for the chip supply, it was two things. It was Corona, where they slowed down the production because they thought that they will not sell that much. This was one thing, and the other thing was like now this in this Renaissance plant where they had the fire, and in the US where they had the blackout in this one area. So there were quite a lot of chip suppliers there, and I know that Infineon was affected there. So we had a combination out of like pandemic and some mishaps.
All right. So thanks a lot. So I hope the people who find this video find it interesting. It's like a movie. As a movie is 76 minutes at least. We're past it's like a feature film. So they didn't have to watch a Netflix movie, and they watch this video instead.
Okay.
All right. So thanks a lot. And maybe do you want to mention just something? What's been happening this year with the embedded world? Was online? That we still able to connect with all the people, or do you just do a lot of Zoom calls and Teams and all this stuff? Or what do you think?
Yeah, we do Teams and Zooms and Google Meet, and in Germany, SenfCall, which is based on Big Blue Button. Of course, to connect with all the people within my company, because we also have trainings, usually trainings, classrooms trainings here. We took the room which is was used for classroom trainings and made office out of this to have a higher distance between the people. But my team really likes to come to work. So we try to separate as much as possible. Some do home office so that we're able to keep the distance and not get anybody sick. And I've been connecting via phone and these different meeting options with the different people I know.
Cool. All right. So hopefully some people can watch. Leave some comment, and you can maybe if there's some good follow-up, you can answer to the comments, or share the video around to the right people if it could be an interesting introduction into what you're doing right there. And do you have would you say there's a lot of competition in the field of education in this field, or this is what you're doing is trying to do something very unique?
I think that we are taking it a step further and that we're really benchmark and unique there, because we are taking this animation and we are showing the technical things. So it's not like that you see one person talking and maybe some PowerPoint slides, but we really take the people through and we have the interaction. So you usually don't have like 2 minutes where you just can sit and listen. You have to switch some button. You have to do something. So you have to keep active. And this means that you're taking in the information a lot better. And there's a lot more planned and in my head. So we will combine it with knowledge management. We will have different navigation paths inside. And step by step, this is really something my heart is beating for. So it's something I want to take further, and we will every like euro we are earning, I will put into increasing the team and get the next things implemented. So I have a lot in my head.
And this is the perfect time for everybody to improve themselves and learn new skills, and all the people who want to join this industry and people who want to upgrade themselves, right, for the next gen of crazy cars that are coming out with all these amazing features and all this stuff. Did you talk about the price of your platform?
Yeah, currently it's 640 euros per year, the yearly subscription, but we will increase it. So I made a marketing workshop and we did some pricing models, so it will become 990 soon.
Is it possible to kind of like price it based on where people are? So if they're in a country where maybe the standards are lower, could it be lower price than people living in Germany or something like that? Or
we'll have to think about this, but currently this we did not consider yet. And also it would be good to get the feedback. So you also have to take care of all the tax systems in the different countries. So the web shop is for more than 30 countries, the most relevant for automotive, but we did not cover everything yet. So this means also some things you have to take care of, all the tax system and how to write the bills and so on.
Maybe the tier 1 suppliers or the car makers can buy like a package for all their employees and something like that?
Yeah, so we have different options. We can either have that you have one domain and we have a voucher concept, so that you are paying like for 50 or 100 people access, and then we give the voucher to the HR department, and they do their organization there. And even if it's even bigger, then we can make a direct server connection and a special instance for this company. Like for the big OEMs or suppliers, this would make sense to have like a direct access where all the employees can access with single sign-on, and you don't need a special login.
All right. So I hope some of these guys are watching this video and thought my questions were okay. And then they can just click through and sign up all their employees in one click or something like that. All right. So thanks a lot for this talk, for explaining everything.
Yeah, thanks a lot for listening and for your questions.
Thanks everybody for watching. Thank you.
Bye-bye.